Hi, this is Mr. Biter, and these are the notes for changes in matter. Here are the words to know for this unit: solid, liquid, gas, kinetic energy, melting, freezing, vaporization, condensation, sublimation, deposition, chemical bond, chemical change, physical change. The key questions for this unit are: what is a physical change? What is a chemical change? What are the three states of matter? How are they different? What are the changes in state? How do they occur? First, let's take a look at what is a physical change. A physical change occurs when a substance changes only form or appearance. Examples include cutting wood, shaping Play-Doh, breaking glass, ripping paper, boiling water, melting ice cream. For all these examples, they're the same thing before and after the change. Wood is still wood after you cut it. Play-Doh is still Play-Doh after you shape it into something else. Glass, though it is broken, is still just glass. And the same is for all of these. A chemical change is different. So let's look at what a chemical change is. A chemical change is a change in matter that changes a substance from one thing into another. Chemical bonds are broken and or made. Remember, chemical bonds are the things that hold elements together when they're in a compound. So we're either having elements come together or go apart from their bonds. They're making compounds or breaking compounds. Examples of this happening include rusting, baking cookies, frying an egg, bubbling from mixing baking soda and vinegar together, and burning gasoline. All of these are examples of new things being made. Whenever a new substance is formed, like iron oxide or rust being formed from iron and oxygen, we know there's a new substance that is a chemical change. What are the three states of matter, and how are they different? There are three main states of matter: solid, liquid, and gas. There is a fourth state of matter called plasma, which is ionized gas. Matter can exist in one of these four states. All the matter around us is in one of these states. Commonly, we'll see water exist as solid ice, or liquid as it comes out of your water faucet, or gas, such as the water vapor around us that can make humidity. And there is a fourth state of matter we're not as familiar with, but we see this in neon lights, lightning, and other types of ionized gas. Solids have a definite shape and volume, and these particles vibrate in place, like in this picture here. There are crystalline solids as well as other solids called amorphous solids, but there is a regular pattern when we have a solid, and the particles are close together and do not move much. In a liquid, there is a definite volume, but they'll take the shape of the container they're put into, like in these examples here. And the particles are further apart than in a solid, and they're moving faster. In a gas, there is no definite shape or volume, and they'll fill whatever container you place them into. Just like if you blow up a balloon, that'll expand to take the place of that gas you have put into it. And these particles are moving at high speed all the time, and they have a very high kinetic energy. Matter can change from one state into another, and these are the different states that they can be in: solid, liquid, gas, and these are the changes in state for each one. Some that you are familiar with include melting, like your ice cream melting from a solid to a liquid. More uncommon ones are solid to a gas, which is sublimation, or a gas to a solid, which is deposition. Take a note here about how heat is either released or absorbed from one case to another. If we want to get liquid water to turn to a gas, we need to add heat to it, and heat will be absorbed. Same thing here. If we want ice to melt into water, we need to apply heat, and that heat will be absorbed by that solid, making the particles go faster and turn it into a liquid. However, we need to remove heat from that water, that liquid, to then turn it back into ice. And that heat is being withdrawn or released from that water to make it ice. And that concludes our presentation.